Yeah, good morning everyone. I've just posted the upload link of yesterday's lecture in my YouTube channel and of my YouTube channel in the WhatsApp group. So those who had missed it yesterday or need to revise it would benefit from that as such. And something that we were speaking about yesterday and somebody has posted a few things about it is firstly, of course, the fact that I just adjust the camera. Yeah. Uh, See that this is the vertical axis of the earth. Okay, this is with reference to the climate change and the Milankovitch cycles that I was referring to yesterday. So this is the vertical axis. However, you see that the earth does not stay vertical like this. It is originally tilted at its axis, so it's going to go like this. Okay, it's going to go like this. And this tilt in the axis, as it is called, axial tilt, it varies between, let us say, 22 and 24. So within a cycle, now I forget the number of 1,000 years, we are going to start with that slide. But as there's going to be a technical issue when I go into the PPT and come out of it to show you this. So just for the sake of convenience, I'll explain this on the globe, and then we'll go to revising what we were speaking about, the Milankovitch cycles yesterday. So yeah, anybody has a question issue? Somebody's mic is on. Okay. So we'll see that 24 is this, and this is the vertical. However, this is 22, let us say, and this is 24. Okay, so it is this small wobble that the axial axis has as such. Okay, now the precision, as far as the precision is concerned, it actually happens like this. Now, this is the axis. Okay, if this is the axis, okay, tilt is, as I said yesterday, and I was using the stylus to show that it is a two-dimensional direction, up and down and up and down and up and down. As far as precision is concerned, while this up and down happens one, and while this Earth revolves around the sun at a great speed, what happens is this tip here, okay, it tends to wobble like this also. Okay, it goes around, round, around its own axis. It happens like I can give you an example of a top. Okay, I don't know how many of you all have spent your childhood using trying to play a top as such, because those times are gone wherein children used to have these indigenous games. Okay, nowadays it's more of those international games and electronic games and so on and so forth. Anyway, so if you can imagine a top, okay, you have just slung it into action. You sling the top into action, and it starts rotating very fast around its axis. Now, as the energy that you have supplied to that particular rock top comes down, you'll see that gradually it starts waving around its own axis. So that is what I would say is precision, as far as what Milankovitch meant to say. And the third thing, as he has also said, is it's all related to the axis of say the path of revolution, which we have while going around it as such. I will just share my PPT. Yeah. Okay. So this is, I think, one of the last slides that we did yesterday, and as I said, that you can just use this clip or this URL to go to the clip, this one on YouTube, to identify a small clip which is there as far as the Milankovitch cycle is concerned. Just to revise it, okay, you'll see that we have three of them. The axial tilt, which I showed to you, is a cycle of 41,000 years. Okay, cycle. That means it will start at 22, go to 24 or 24 and a half, and then it will come back to 22 in 41,000 years. And then we are going to have precision, wherein, as I said, that the axis is going to doze into a wavy motion. It's called as a precision. And it has a cycle of 26,000 years. The geographical aspects of these would be that as far as the axial tilt is concerned, more the tilt, larger is the tropical regions. That means the distance between the Tropic of Cancer and Capricorn is going to increase, and lesser the tilt, okay, the distance between the Tropic of Cancer and Tropic of Capricorn is going to decrease. When it decreases, you're going to have a colder earth. When it increases, you're going to have a warmer earth. Okay, because say another reference about these two lines, I think we did speak about it, but I'll just repeat it here, is the limit to which the perpendicularity of the sun's rays travels. Okay, in the sense, now let me, I can't get it now, but again, that would be too small in that particular window. I'll try to, okay, in the sense that, okay, if I'm going to hold the earth like this, okay, let us see and try about it. Somewhere here is going to be the Tropic of Cancer, somewhere here is going to be the Tropic of Capricorn. So the sun keeps on moving as far as its perpendicularity is concerned, from June to September and December and March, and June to September and December and March. It keeps on shifting like this. Okay, so if the angle is going to be more, it's going to go more up and down. The angle is going to be less, it's going to just move around in a lesser angle. Then, as far as the axial precision is concerned, that is to do with these dates. Okay, we'll see that it will so happen that if you have an equinox on 23rd of September, it will shift to 23rd of December, and the winter solstice on December will shift to March, and the equinox on March will shift to June, 21st of June, and the summer solstice of June will shift to this. Okay, so it will keep on jumping. Okay, after one round, it will move ahead and then ahead and then ahead. Now, this is going to be a cycle of around what? 7,000 years each, approximately, less than 7,000 years. So one shift is going to be 7,000 years. The second shift is going to be 14,000 years, and then 21,000 years, and then 28. Of course, it's 26,000 years here. So let us say around 6,500 years. It keeps on changing. Okay, you'll see that as far as human history is concerned, okay, the observed history is not more than 3,000 years. We say that man started this and that, but the proof to that is all interpretational rather than anything else. Okay, and then the last type of it is how the earth goes around the sun, and the path which it takes, which is called as the orbit around the sun, and it moves from being circular to elongated, and in that elongated also, it's interesting to note that it's not, say, the elongation is such that the longer axis and the shorter axis will make an interesting difference. That means there is going to be a position of the sun wherein it will be, the earth will be nearest to the sun. That is going to be called as perihelion. I did refer to it yesterday also. Perihelion. Helion. Helios comes from fire. The sun is a ball of fire, so that's why perihelion and aphelion. Okay, perihelion occurs somewhere in Jan, and 6 months down the line, somewhere in June, you're going to have an aphelion as such. Okay, it makes minor changes, but yes, definitely it makes changes as far as the whole climatic issue is concerned. So that is about the climatic change and what Milankovitch had to say about this. You'll see that the longest cycle of all, it's a cycle of 1 lakh to 4 lakh years, around approximately. It varies between that. Okay, then we come to this aspect. Okay, that why did I say yesterday when we calculated the circumference that the Earth moves in around the sun is approximately 150 million kilometers, and 2 pi r, yesterday we calculated it somewhere around 900 million kilometers, and you can just imagine the speed at which the Earth tends to move, okay, and rotate, and of course, the eccentricity that happens as far as this axis is concerned. We spoke about the dates as well. Now, what actually happens on these dates is the fact that now this is the winter solstice, so this is going to be 23rd of December, and this is going to be the vernal equinox, which is going to be March, let us say 23rd again. This is 21st of June, and this is going to be 23rd September. Now, the geographical significance of this, on this day, 23rd of December, the nearest point from the sun would be the South Pole. Okay, and on this day, the nearest point is going to be the North Pole. And as I said, on these 2 days, all points are supposed to be equal, and that's why we are supposed to have 12 hours day and 12 hours night, which we say is not exactly the geometric explanation, is not the geographic explanation, because the geometry of the Earth does not fall into the geometric shapes that are required for these perfect calculations as such. So there is a bit of variation, and that we have been noting through these various slides that I have been preparing from the screen, on the screenshots from the weather and radar app. I hope, though I stopped explaining to you about these things, you would still maintain and keep posting the information about what new things you tend to gain, and a bit of interpretation of that on our group yesterday. That reminds me, I was speaking about climate change and what you actually call as a climate change, and what you actually refer to as an effect of climate change. And I said that while there are effects of climate change which could be extraterrestrial, that's from space, we have terrestrial points of climate change also. We're going to come to that, as I said, as a part of geomorphology. But then yesterday we spoke about sunspots, and somebody has posted an information on sunspots as such. And the impact about this is sunspots operate in a cycle of around 12 years. Okay, from having least amount of sunspots on the surface to having a maximum amount of sunspots on the surface, okay, happens to be one cycle. And you'll see that when the sunspots increase, you'll see that you have solar radiation, increase in the solar radiation, and that at a particular point of time, let us say around 3, 4, 5 decades ago, used to hamper electronic communication. Okay, the radio sets, etc., used to have a lot of variations, and of course, the speed at which the radiation moved was called as solar wind, and so on and so forth. So all the changes that took place with reference to these sunspots and or sunspot activity, I would rather say, could be noted as a minor change in the climatic patterns for various regions as such. So that's about sunspots for us. And then this is one diagram that I was explaining to you with regards time and with regards seasons. Okay, for seasons we need to understand latitudes, and for time we need to understand longitudes. Okay, of course, one of the basic advantages of latitudes and longitudes is location. You have a longitude and you have a latitude. The cross point is going to give you the exact location mathematically of any place. Okay, you can take any of these. Let us say this point on the coast of Mediterranean Sea, or it could be say this point near the Suez Canal. Okay, if I need to give the absolute location, if you remember, we're speaking about it in the themes of geography. What I do is I take the longitudinal value, crossing it, and I take the latitudinal value, and the intersection of both of them gives me the so-called absolute location of that particular place as such. Now, just as I said that this is not a part of our syllabus as such. But as geographers, we need to revise this. We may be knowing this, but then we need to revise this as such. Now, to start with, as far as latitudes are concerned, you'll see that these are horizontal lines which run, okay, which run east-west. Now we call them as horizontal lines because normally we do refer to them in two dimension, and that is why we call them as horizontal lines. However, towards the left of your screen, or rather towards the center of your screen, you see the sphere, and on the sphere, of course, these are concentric circles. Concentric circles is basically circles that fit into each other. Okay, so if I'm looking at the Earth from the top, okay, the North Pole is going to be a point, and the equator is going to be the outermost circle. These are concentric circles in two dimensions. These are going to be horizontal lines. The circumference of these concentric circles keeps on decreasing gradually as you move towards the poles. One. And at the poles, in fact, it's not a circle, it's just a point. Okay, the North Pole is just a point. How do I measure this? Okay, all I have to do is I take a particular place on the surface of the Earth. Let us say I'm taking this 30-degree latitude. It's marked already, but I'll let you know. This is 30-degree latitude, and I trace it all the way here. It comes here. Now what I do is this point along the 30-degree, I trace it to the center of the Earth, and I have the horizontal at the center of the Earth. Okay, so the horizontal and the point from which I'm drawing a line to the center, I'll measure that. This is going to be 30 degrees, and that's why all points in this line, all points in this line are going to make what is going to be called as the 30 degrees latitude. The same thing I'll do for 20 degrees and 10 degrees and all the way to 60, 70 and 80 degrees also. Now, if you see here, the area, okay, 50 degrees to 90 degrees, 60, 70, 80, 90, 40 degrees, and this 0 to 50. Okay, you'll see that this area is less, and that's why you'll see that the rate at which the sunrise and sunset change time is very high in higher latitudes, while as you move towards the equator, now today again I was looking at Medan, and possibly tomorrow Kuala Lumpur, and see that Singapore is at around this point here. So Singapore is around this 1 degree north latitude is the location of it. So it would not be before another week or so that Singapore is going to have an equal day and equal night as such. Now, in spite of the fact that you have these rounded latitudes 10, 20, 30, 40, 50, 60, 70, 80, 90 in the northern hemisphere and the same number in the southern hemisphere. Okay, how many primary latitudes would you have in all, totaling both the hemispheres? Primary 10, 20, 30, 40 in the northern hemisphere, 10, 20, 30, 40 in the southern hemisphere, all the way to 90. What would be the count of latitudes that you would have?
180.
Okay, he says 90 in the northern hemisphere, 90 in the southern hemisphere. That's 180. How many of you all agree to it? Or anyone else has any other opinion about this? It's a larger number, it's a smaller number. Okay, while we are referring to 1 to 90 and 1 to 90, okay, we forget that 0 degrees equator is also a valued latitude, and that's why it is 181 primary latitudes is what again I want students of geography to remember henceforth. Just clear this and then we'll go into further details. Yeah, so let us enjoy this further. Now it's very say if I want to explain it to a layman, a geographer explaining to layman as to how do I draw latitude, I would say that I would cut the earth vertically. I'll cut the earth vertically into two halves, and this is how this would look in the, say, the face of that would look. This is going to be the center. I'm going to take a horizontal in the center. Sorry, I'll just redraw it. Give me some time, make it small so that it does not create a problem for me. It's a horizontal. I'll take any point on the surface, any point on the surface, any point, let me say this point. I want to measure the angle of that. I'll take the center and join this, and I'll measure this angle. This is all happening in 2 dimension. Okay, I'll measure this angle. It's very similar to what we did here. Okay, this could be 75 degrees. So I will draw a line along this line of all the points in that line, and all these lines points joined together will give me the latitude of 75 degrees north. I do it the same way in the south, so I'll have these in the south also. Then we have, besides these rounded latitudes, I call them, you have some latitudes in these numbers, 23 and a half, 23 and a half, north and south, the Cancer and Capricorn, the latitudes. What is the importance of geographical importance of that? You'll see that the perpendicularity of the sun's rays, these are the limits to the perpendicularity of the sun's rays. So any place beyond this point, any place beyond these points will, what does perpendicularity also mean? Any place beyond the points of 23 and a half degrees, as long as the axis of rotation of the earth is 23 and a half, will not have overhead sun. It will not have overhead sun. Along the latitude, you will have overhead sun for only once. All places between these two latitudes, all places will have it twice. And what is this overhead and once and twice also called as? This is called as the zero shadow day. It's called as the zero shadow day. So that is about latitudes, and you'll see that when the sun is in the northern hemisphere, it is the summer of the northern hemisphere. When the sun goes down to the southern hemisphere, it's the winter of the it's the summer of the southern hemisphere. Now that we say that the sun goes in the northern hemisphere, and that the sun goes to the southern hemisphere, is something that we use for geographical convenience, I would say. It's a geographical liberty that we say no one moves nowhere. They are all moving along their own fields. It's only that the tilt in the axis makes us feel that the sun, it's a relative movement, I would rather say. It's not an absolute movement. It's a relative movement. Because the earth keeps going around it, it appears that the sun rises in the east and west, sets in the west every day. At the same time, season-wise, the sun climbs up in the northern hemisphere during the summer of the northern hemisphere, and the sun climbs up in the southern hemisphere during the summer of the southern hemisphere. So,
Sir,
yes, please.
yes, sir, I'm not getting this overhead thing.
Overhead in the sense, okay, now this is an individual, right? The other day we said that this is going to be your east and this is going to be your west. Okay, so the sun now, let us say, rises in the east early morning. It comes up, say, let us say this is now 9 o'clock and 10, 11. And we say that noon time, 12 o'clock, which again I said that it is not, say that precise when the country is large, okay, but it is believed that geographically, noon time is the time where the sun is exactly above the head of an individual in the sky. This position is called as the overhead position. And then, of course, it climbs down and it sets in the west. Getting it now?
Yes, sir, but how does that happen once between 23.5 degrees and twice, yeah, as you have written there?
Yeah, yeah. Okay. I'll let you know that as well. Now, if we go back to this diagram, and I will just clear it off so that we have no confusion. Okay. Now you'll see that this position 1, this is a winter solstice. What is happening? That the south pole is facing the sun. Now, if I'm going to see, if I want to draw a perpendicular, or rather, I want to draw a tangent. Most of y'all are, all of y'all are science students, so you know what is a tangent. Can anybody tell me what is a tangent? What
The
is the
line which
tangent?
meets circle at only one point.
Yes, the line which touches the circumference and passes through a single point is called as the tangent, right? Now, if I want to draw a tangent, okay, I'm going to draw a tangent, but there is one more condition, that the sun's rays have to be perpendicular at that tangent. The sun's rays have to be perpendicular at this tangent. Now, this geometrical meaning into geography is if a person is standing at that tangent, okay, the sun's rays are going to be overhead. Now, if I'm going to draw, I'll try to, because it's all shaky here, but I'll try to draw a tangent here. Okay, I don't know whether at that scale of your mobile screens you are able to see this, but if I draw a tangent and if I bring one ray from the sun all the way down here, the only point at which the angle is going to be 90 or it's going to be a right angle on this particular day is the Tropic of Capricorn, the only point. Similarly, the same thing will happen here on 21st of June only on the Tropic of Cancer. Okay, now here it will not go this way. Further, it does not go because after December, it starts traveling northwards. And this is going to be March, as I said earlier also. And then after March, it will go further north into the northern hemisphere. In June, it will touch this line here. And then again, it starts its southern journey. So all points beyond this, what I said, meant that all those geographical locations beyond these tropics will not do that. And the speed at which the Earth is traveling around the sun, it gives them a time of 1 day only. But what happens is these points between these two, they come under the direct rays of the sun twice, once in this half and once in this half. And that is why all places between 23.5 degrees north and south will have 2 zero shadow days. The absolute latitudes of Tropic of Cancer and Capricorn will have it only once. And all the points beyond these two latitudes will never have a zero shadow day because the sun will never get overhead. Have you understood it, or I would still should be repeating it again?
Sir,
Please
I've
repeat,
understood.
sir. Sir, please repeat it once.
What have you not understood? Now you'll see that
Uh,
repeating again would again. I'm not exactly at a level to know what
Seasonal
you are not.
configuration of Earth and Sun.
Seasonal configuration of the Earth and Sun. Okay, I'll use this diagram again. Okay, you'll see that here the southern hemisphere is facing the sun, more of it. Okay, because it's not only the south pole, the point beyond the south pole also is going to be facing the sun. While here you'll see that this area is in darkness. So a larger area of the southern hemisphere is facing the sun, and that is why you have a summer here. And this is because of the tilt in the axis. Let us start our discussion there. The tilt in the axis is 23.5. Okay, and the dotted line shows us the tilt in the axis. Okay, this I would say that this should be the vertical, and this angle or this angle, whichever you say, is 23.5. So while say from let us say from September to December, it gradually moves into the summer of the southern hemisphere. Okay, it's at its peak, I would say here, and it gradually starts going down. Now again, when I say it's at its peak, I'm referring to a geometrical location and geometrical reference, because if I go geographically, it may confuse them, but then I confuse you all. But I have to tell you all that there is always a lag in this also. And that is why many a times I always believe that time has come that we correct all these geometrical, so-called geometrical diagrams and the geometrical explanations to it. We should rather move to the geographical explanations of this, because you'll see that a layman's logic to explain this would be that if this is the point wherein the sun's rays are going to be perpendicular at the Tropic of Cancer, and this is the point wherein the sun's rays are going to be perpendicular at the Tropic of Capricorn, This is going to be the day which should be the hottest on the respective latitudes, right? However, it does not happen so. You'll see that the highest temperatures are reached somewhere in July in the northern hemisphere, and the lowest temperatures, or you could say the highest temperatures in the southern hemisphere, are reached somewhere in Jan. It's around 15 days after the sun has actually passed it. Now, why does that happen? Because you'll see that it's not a sort of what we call as laser heating, that you point something and it starts heating there. Okay, you'll see that the energy from the sun comes gradually. It crosses the layers of the atmosphere. It reaches the surface, and it is then the surface which starts heating the atmosphere as such. It's not direct heating; it's an indirect heating. As a consequence, the highest, say the max temperatures and the minimum temperatures are deferred from those geometrical locations that we tend to put the Earth at. Okay, say 23rd of December and 21st of June, and so on and so forth. Possibly the same reason why we don't have equal hours of day and night, which we geometrically say should be on 23rd of March and 23rd of September. So this is very funny and amusing, but that is how we need to look at it. And here is where you see that reality is a bit different than what mathematics and geometry tells you to understand as such. Okay, so you see that while the sun's rays are perpendicular in the southern hemisphere, you are going to have the summer, which again is this half. The summer starts climbing its max and then it recedes. Then the summer of the northern hemisphere starts. It goes to its max and then it recedes. So this is how the seasonal things go, and this is to do with the shift of the perpendicularity of the sun's rays. As the sun's rays tend to get perpendicular, okay, if this is the surface of the earth, okay, the sun's rays keep on shifting. Okay, wherever they are, you're going to have summer, and where they are not, you're going to have winter. When they go back, this is going to be summer, this is going to be winter. Am I clear, or you need more clarification?
No,
Yeah,
sir.
am I clear? Huh?
Clear, sir.
Clear. Okay, fine. So that is about latitudes, and you'll see that latitudes are related to seasons. And if we are referring to seasons, they are all something else that they are related to is climates. Climatic changes take place according to the latitude. They don't take place according to the longitude. So what changes along to the longitude? We have had a long discussion on this, but just in case you are not able to link the logic, I will again refer to that. What is a longitude and how does it differ to a latitude? You'll see that latitudes were concentric circles. So a consequent latitude was smaller than the earlier latitude. Longitudes is not that particular way. In fact, longitudes are sometimes they are also referred to as semicircles. Okay, and these are lines which run from the one pole to the other. Secondly, they are not parallel to each other. They diverge from a particular pole. Now, whichever pole you take as a point of reference, they will diverge from that pole and they'll converge into the next pole. Okay, so if you're starting from the north pole, they start diverging and they'll converge into the south pole. Okay, like this. Okay, unlike latitudes which are of different lengths, you'll see that circumferences are longitudes are of the same length, all of them. Some of them are prominent. Now, there was this interesting thing. While we measure latitude, all we had to do is take a horizontal on the center of the earth, take a point and get it to the center and measure the angle. And let us say that we said that, okay, this is 45 degrees of latitude here, and so on and so forth. This was not so easy as far as longitude was concerned, basically because what we had to do is to carve out longitude. You have to cut the earth horizontally into two pieces, northern hemisphere and the southern hemisphere. You cut it and then you hold it to yourself. Okay, what do? You have a circle again in 2 dimension. You have a center. Okay, now what you have to do is you have to mark a point of reference because you're going to measure the angles from that point of reference. And that point of reference is 0 degrees longitude, today also called as the GMT, 0 degrees longitude. In fact, you'll see that this line here, which reads the prime meridian, they have cut the earth along that very line as such. So you need to join the center and this, and then you measure the angles in a horizontal way. Okay, you'll see that you'll measure the angle from where? From the Greenwich meridian. And that is why I said that, okay, if this is the west and this is the east, okay, India is going to be somewhere here. And if I plot this and then I measure the angle of Mirzapur, it is going to be 82.5 degrees east. I would advise you all that you revise it. I'm very sure that these geometrics and references, while a teacher moves from 2-dimension to 3-dimension and back from 3-dimension to 2-dimension, would definitely make confusion as far as 90% of the students is concerned. I'm not referring to that 5% of those brilliant heads which would understand it before I have tried to explain it as such. Now, obviously, there would be a question from you all, sir. You said 90% are not going to understand, 5% have already understood it. What happens to the rest of the 5%? I believe the rest of the 5% should make a very valiant effort to understand it. Now, what are these efforts going to be? You can go to the YouTube and you can search for latitude, longitude. You'll have these small clips. In fact, a better way is those who have subscribed to my channel, YouTube channel. Okay, if you have subscribed to my YouTube channel, you could go into my YouTube channel, and I have made 2 very short videos on explaining latitudes and longitudes. I think, and that's on the basis of responses that I've got from school children. Leave aside college children as such. I have many lectures for school children also on geography, because many a times they find themselves confused about it. So I do keep on visiting to various schools, trying to make geography simple at school levels also, particularly all these geometrical dimensions as such. I have 2 short videos. I will try to post the links of these videos as well, but that should take time. Those who can locate those videos on my YouTube channel, you could go and post a link of it on our group so that others also can have a look at that. So what am I going to do now? I'm going to measure it all the way till this point. This is going to be 180 degrees east longitude. Okay, and then I'm going to do the same thing here. So I'm going to have 180 here, and I'm going to have 180 here. So how many longitudes now would I have in all? Just I ask you all, how many latitudes you are supposed to be having? How many longitudes, prime longitudes, should we be having?
$180.
That's only this part. And
360.
360. You all are sure it is 360? Or it should be a bit more or less numbers? Don't you feel that
Sir,
180 east and 180 west is going to be the same?
359.
Okay, 359 is the answer. Is this right?
Sir, 0 will also be same, na?
Exactly. Though it comes to 359, you have again forgotten 0 degrees. So you add that 0. So 359 plus 1 is going to be 360. So 360 degrees of longitude is actually the right answer. Okay. So as I have explained that latitudes are angles measured in this particular direction, and longitudes are angles measured in this particular direction. Also, do remember what I've said a few days ago, that when we started with the concept of longitudes, etc., 0 degrees, France was having its own 0 degrees and England was having its own 0 degrees, until and unless it was internationally agreed that the 0 degrees in England would finally be the 0 degrees to be eventually called as the GMT. And then as far as measuring world time with reference to GMT is concerned, I've already explained it to you in an earlier lecture. A few more things remain about it, and somebody was referring to asking me about the seasonality. This is how the seasonality tends to change as such. This is the angle at which the, see, this is actually 23 actually is very small. Okay, but as I said, we again take the geographical liberty to show it, and because if we show it at an actual scale, we would not understand it. Okay, so we do it this way, and then of course these prominent latitudes, Cancer and Capricorn, divide the zones. Okay, this becomes your torrid zone or the tropical zone, and then this becomes your temperate zone. And of course this is going to be your frigid or polar zone as such. Then this is how we measure latitudes and longitudes. I've already given you the differences between latitudes and longitudes. A question which we normally do mug up and attempt at 5th and 6th standard, but eventually we again get say lose this over the period of time. That's basically because we try to learn it up, rote learning. Okay, try to understand the logic, and you will never forget the essence of it. Okay, what is actually a longitude? What is actually a latitude? How are you going to differ between them? What are the points of similarity? What are, which in fact are more? What are the points of differences between these two as such? Commonality is that both of them are imaginary lines. You cannot go to that particular, you cannot find latitudes and longitudes drawn on the surface as such. Okay, this is another view of how we measure the latitudes and longitudes. Okay, this is another diagram. The 0 degrees meridian and 180 degrees meridian. They divide the world into two hemispheres, the eastern hemisphere, the western hemisphere. I said that time in eastern hemisphere is always plus of Greenwich meridian, and time in the western hemisphere is always minus of the time at Greenwich meridian. That means what is happening at the prime meridian has already happened here, and it has yet to happen here. Okay, already happened and yet to happen. That is the difference between the eastern and the western hemisphere. We have already referred to this, but we'll quickly go. Okay, facts about longitude. All are known as meridians. Yes, there was a concept which I missed out. I want you all to think about what is a great circle till then. Longitudes run north-south. Measure distance between east or west of the prime meridian. East or west of the prime meridian. The farthest of the equator, they will meet at the poles here down as well. And across the equator, they cross the equator at right angles. If this is the equator, it's going to make a right angle. It's going to make a right angle. Okay. Then lie in the planes of axis that passes through the Earth's axis. So you'll see that if I'm going to take any longitude, I will take number 1 or number 2 or number 3 or number 4, and I cut through that. Let us assume that I make a cake of this particular shape. Nowadays, it's possible to make a cake of any shape and size and color and photograph as well. Okay, and if I'm going to cut it through, okay, every cut along the every longitude is going to pass through the center. It will pass through the center. And my answer to this question lies there. Let me give you a hint. All of them are of equal length and are halves of great circles. Okay, you'll see that any longitude I cut the Earth through. Okay, 0 degrees, 10 degrees, 50 degrees, 65, 67, 180 degrees. Okay, you'll see that it will divide the Earth into two equal halves. Now give me my answer. What is a great circle? And which is the largest great circle on this planet? Any idea?
Equator.
Equator is the greatest circle, largest circle, great circle. And what exactly does a great circle mean?
0 degree latitude.
No, no, no. I gave you a hint when I was explaining these characteristics of longitude. That line along which if I cut the earth, now let me be very clear with this particular diagram. Okay, I am not able to see a chat box, so those who are posting their comments in the chat box, will please unmute themselves and give your answers to me. I'm not able to see y'all and your chat box as well. We'll see that if I'm going to use any of these longitudes here and try to cut the sphere of the earth, you'll see that that cut will pass through the center of the earth. On the other hand, if I'm going to use the same principle for latitudes, if I cut through this latitude, if I cut through this latitude, if I cut through this latitude and this, you'll see that they will not pass through the center. The only latitude probably will pass through the center is 0 degrees. So equator is the only latitudinal great circle, while every longitude is a great circle. Going into the actual length, because the equatorial circumference is maximum, that is why it is called as the largest great circle, while all longitudinal great circles are of equal length. Got my point?
Yes.
Or you want me to explain it again?
No, sir.
Okay, so this is another way of how I said that we cut the earth into two. We mark a 0 degree and then we start measuring the angles towards the east and towards the west, and here we come to 180 degrees west. This is 180 degrees east. Okay, and then exactly opposite to 0 degrees is 180 degrees longitude. 180 degrees longitude is also called as the international dateline. I did speak about it yesterday also, and you'll see that in competitive exams and otherwise, they always ask you a question that if you are moving from the Western Hemisphere to the Eastern Hemisphere or from Eastern Hemisphere to the Western Hemisphere, are you going to gain time? Are you going to lose time? And so on and so forth. And having said that, it's not, many times it is not as simple as that. They would say that an aircraft takes up from Sydney and it lands in let us say California 10 hours as such. So if the starting time is so and so, what is the difference? What time will it land, and so on and so forth. So as the levels of the exam get higher, the questions on this tends to get more complex as such. So what you have to do is actually you have to equate time in Australia to GMT. Then you will equate time in USA to GMT and that zone also. And then initially you calculate it in that sense, and then you add the hours of journey. I don't know whether you would be able to understand this because I'm not in front of you. If had it been in front of you, I could have made it much more easier. It's not that difficult, and as I said, this is one of the negative things that tends to happen as far as online education is concerned. Anyway, you'll see that another important thing is that the international dateline is not as smooth as a longitude as all other longitudes. You'll see that this here is the international dateline, and because the day changes, you'll see that they have taken care that it passes all the way through the water surface. Here, in fact, you have a group of islands which belong to a particular country. So all that country is being taken into, and then it goes further down as well. So that is again one thing that I wanted to refer to. This is something that I have already spoken about as to how the angles tend to change. Okay, you'll see that we said that if this is December, okay, this is 23.5 here. Okay, you'll see that the perpendicularity of the sun's rays is here. While in June, the perpendicularity of the sun's rays is here. And then it keeps on moving between these 2 points. Okay, after December, it will travel up. After June, it will travel down. And on the day of equinoxes, you'll see that the perpendicularity is on the equator, and that's why it is called as an equinox. Is a point I had to make out of this particular diagram. I would leave you with a question today once again by showing you all this enlarged diagram. Okay, we were speaking about December. Sorry, see the topmost diagram. I'll just write it, and then this is December. This is March and June. Sorry, March and September, and this is June. Okay, now let me once again throw some light upon this. Now, this is how the zone of illumination will look. We've already said that on the Tropic of Cancer and Capricorn, on those respective days, it's going to be perpendicular. I want you all to give me what is the geographical explanation of 66.5 degrees north and south. For that, I would have purposely put this on a magnifier so that you understand. You'll see that the darkness is touching here. This is the Arctic circle. This is the Arctic circle, right? And this is the Arctic circle, which is in light here, and this is the Arctic circle, which is dark here. Anybody who can explain me the say geographical importance of 66.5 degrees? If you are not able to give me your answer today, I will wait for your answer in the coming week as such. Coming week, we are going to do this as well. Another interesting and important thing, which is not a part of your syllabus, but I believe that we students of science particularly need to understand this as well. So if you have my answer ready, we could take up that, or what I'll do is I'll just stop sharing and I'll move out of this and let me return back to this. Fine. So if you have your answer for the geographical importance of 66.5 degrees, you could just unmute yourself and let me know your answer. By the time others can please start typing their names in the chat box as a process of marking your attendance. And if you've finished marking your attendance and if you have no questions for me, you can leave the meeting and join your next lecture, or you can just unmute and ask me your question as such. Yeah, any questions anybody has for me?
Sir, the first part of our lecture, that precision, eccentricity, and the tilt, does these things happen at the same time?
No, they happen in combination. It would be a very rare occasion wherein it's a dynamic thing. It's happening continuously around us.
Okay.
Okay, so at any point of time, for example, now the Earth is going to be at one angle. Okay, the wobble is going to be at a particular location, and the rotation or revolution of the Earth around the Sun is going to be at a particular thing. Everything is in dynamics, but then that is how you tend to understand that.
Oh, okay, sir.
Thank you, sir.
Sir, the
Yes.
66.5 degree angle, is it because of the tilt?
Yeah.
That tilt.
And I've already explained you the
Yeah.
geometry of it, that you add 23.5 and 66.5, it comes to 90 degrees. I want you all to give me the geographical reference of it. The answer was in the diagram itself. If you have been very watchful as to what I was saying and what you are seeing in front of you, you would have had an answer ready for me. Anyway, it does not matter. You can think about it and you can post the answer in the group of WhatsApp, or we'll take it up next lecture. If you have no more questions, I'll first stop the recording for the day. This will be available to you